Hi everyone, and welcome back to another BTLO replay. Before we jump into bad logic, be sure to follow us on X, LinkedIn, or join the Discord server to keep in touch with the BTLO community. Links are in the description below. Right, let's get started. Hello defenders, and welcome back to another BTLO replay. My name is Daly, and I'm going to walk you through the retired investigation Sharp attack. So, Sharp attack is a medium reverse engineering investigation. It's based on Linux. Or at least it's running on Linux. That's interesting. Having a look at the tools, it's mentioning PDF, PDF parser, PDF ID, and Linux CLI. I see a common pattern there with the name of the tools, but let's have a look at the scenario and see if we can confirm that. A large insurance company has received a threatening email stating that all of their customers' data will be released to the dark web if they don't make a payment to the Bitcoin address attached in the PDF file. One of the employees, using the account administrator, opened the document out of curiosity and there was nothing in the file. Very strange. He's sending you the file to inspect. Can you tell if he's just opened a malicious document file? So yeah, it looks like it's related to PDFs, which is interesting. That probably makes more sense with what the tools mentioned there. Okay, so let's jump into the lab. Let's have a read of the questions here. So, what is the creation date of the malicious PDF file? Can you name the malicious code that is being executed in the infected file? What are the two indicators found that will launch the malicious code? Can you tell what is the object number for one of the indicators that are responsible for launching the malicious code? What is the full URI from where the script downloads the malicious file? What is the full path to the malicious file? What PowerShell object does it use to download the file, and what class is it using to start the process? What tool is used to create the malicious PDF file? And what CVE does this malicious file utilize? Okay, so makes sense what we're investigating, I guess. Let's have a look at the investigation folder on the desktop. Let's check the README. Please proceed with caution and do not execute the infected file. All the weapons you need to investigate the file are located in the tools folder. The infected file is located in the infected folder for a good reason. Happy hunting. So let's check the infected folder. There's our PDF. Inside tools, we have some Python related scripts. We have CyberChef. I can see PDF and PDF ID. Okay, so I'm guessing we need to open the terminal for this one. So let's open the terminal up. Let's CD to the desktop and the investigation. It's catalyzed and then to tools. And we'll probably need to. Let's just double check the question. What's the creation date as well? So I'm guessing peep, as in check inside, peek inside, peep DF might be what we need to use for this one. Don't really know what it does, so let's just have a look. Let's make this slightly bigger so we can see all the output. So show document information. Check the hash of the file, whereas total. Okay, so I'm just going to try run this against the file, which is located in a folder upwards in infected. I think it's lowercase infected.pdf. Okay, so we have the hash information there. We don't have a date though. Okay, I'm going to try the -i, which is mentioned on the help, which is for interactive, to see what else we can do with the file whilst it's running with the tool. So we have our little prompt down here for ppdf. And I'll try the question mark. Sometimes that works for getting help. It does an FTP server sometimes anyway. Okay, so we have a list of commands we can run against this. So info makes sense. It's something we could probably check with this. Okay, that's the same thing that we got a moment ago, so that's not all that helpful. What else do we have on here? Okay, maybe metadata. Check the rest of these here. Yeah, let's give metadata a go, because that should be, well, it might contain the dates, I guess. That's the assumption. Okay, so we have a creation date here, but it's not quite in the format we need, so let's just take a look at the question. Okay, so let's type this out. So it's 2018, it's July, and it's 12th, with a T there. 17, we have 42. So let's give that a whirl. Cool. That's nice and easy. So what is malicious code we execute in the file? I think this is pretty easy. So it's asking what is running inside it. I think we have the answer just here. So I'm going to take that and type in JavaScript. Cool, that's good. So let's go back to the help again. 1 second. So up here we have a bunch of objects, and each object relates to some of these things here. I guess these are related to what's actually inside the file. So what are the indicators that have launched the malicious code? So where does this number exist a few times? Might be a good guess. So let's check 12 and see what 12 is doing. So I think it's object based on the above. 12. Okay, so looks like open action will be doing something like open, on open, sorry, I should say, and JavaScript looks like what it's going to run. So my guess is these two. This doesn't work, we'll probably need to hit Google, because I'm not too sure. Is there a space between the two? So let's look at what we have here. Maybe I've got this wrong. So open action will be doing on open. And maybe JS is the actual thing calling, because that's calling a function. So I'm guessing maybe it's these two then. Okay, let's give JS a try. Okay, I guess that makes sense, because they'll just be calling a particular function, and that seems to be getting piped into the open action JavaScript. So I guess it does make sense. Although I'd maybe argue that JavaScript could be potentially correct too. Maybe, because that's technically what would be doing the code launch, I guess. I don't know. We have the answer, so I guess that's all we need for this. But maybe after this I'll do a bit more digging for that, I think. Can you tell what is the object number for one of the indicators that responds for code? So I think we have the object here. So this is all the bits here. Let's give that a try. So this has the open action, and it has the JS, and it has the JavaScript. Yeah, that seems to make sense. Okay, so let's go back to our info again. Let's go over the questions. So we have 13 objects. We have nothing for number 13 on this list here. But let's just double check the objects 11 and 1, because they're embedded files, or mention embedded file. Okay, it is an object 1, so I can see the URL now. So I'm wondering what 13 is now. that makes sense. I guess it's an embedded file, which makes a lot more sense. I'm not sure why I was going towards 13 in my head, but I think we have the information here we need for the answer. So let's try and copy and paste that. Yeah. Right, what's the next question? So what is the full path to a malicious file? So what do we see here? So we have a mention of a folder, which is sneakily named like an executable, just here. And we have download file, so A into B, and A is the cal. So I'm guessing it's this and cal at the end. I'm not sure what ntemp is. So let's take a look at Google. Is it a dot or a colon? Let me double check. It was a colon. So user profile, updated temp, so that we know this has been run on the administrator account. So I'm going to take that part there, the updated temp, and I'm going to type in C users administrator, double check, updated local temp. Then I'm going to add update 12.exe and cal. Cool, that makes sense. So just to show what I've done here, I've gone and checked what env is, sorry. That looks to be the path here. It's got the temp folder afterwards. It's got the update 12 folder afterwards. So that's here. And we can see that it's downloading A, which is this here, this variable, and that'd be cal, into B, which is into here. So into that folder, which makes sense. Okay, so what's the next question? What PowerShell object uses to download the file, and what class uses sort of process? Object name, class name, name process. Okay. So we have web here, which looks to be using web client, so that's the class. And it's using WMI in this video instrumentation, so cool. And we have Win32 process there. So I'm thinking we have the answer here. Let's make sure I've not missed anything on here. Don't think I have, so let's double check. So web client, I'm using WMI to do stuff. We're actually calling Win32. Yeah, that looks right. So I think the answers here are going to be web client, and then it will be WMI, and Win32 process. Cool. Okay, so let's go back to the info for that file. Oh, I've managed to leave. Let's get out of here. I'm not sure how I entered that one. I killed off PDF, so let's fix that again. So we have the objects here. So let's try embedded file. I thought what the question is now. That's a good point. So the question is, what tool is used to create the malicious PDF? So I don't see it on here. Did we try info last time, or is this the output of info? Let's double check again. This is the output of info. Let's try metadata once more. Make sure I'm not missing anything. Okay, so producer here might well be what we're looking for. It's not Google iText Sharp. Actually, I might have to type that in. Let's try that. Yeah, so let's just create PDF files, just reading what's here. I haven't clicked the link, so it looks like it's a PDF creator, so it looks like what's being used. So let's go back to our environment. Questions, what format does it want it in? So it wants that, and the version matches to the way it's formatted here. So iText Sharp 5.510. Let's give that a go. What CV does this malicious file utilize? So I'm going to guess this has come from probably a real life sample, or a real life sample, I should say. So I'm going to give that a search online with the phrase CVE afterwards. And we hit the virus total, that's good news. Do I see the string CVE on here? I do. So it looks like that could be something we're looking for. Let's have a look at Google and just make sure we understand what it's doing. So remote code execution vulnerability exists in the Windows shell does not properly validate the file paths. Also known as Windows Shell Remote Code Execution Vulnerability. This affects Windows 10 and Windows 10 servers. Cool, so that could be what we're seeing. Let's give that a try. Cool. So yeah, very enjoyable investigation. Learned more about PDFs than I knew before, so that's always good. Love learning. Not sure if I did it slightly more unintended route because I only used one tool throughout, but it gave me the answers I needed, so it wasn't wrong, just maybe a different way. But yeah, really enjoyed that. Thanks for watching. Be sure to like and subscribe to never miss a video. In the meantime, remember to join us on Discord and tune in every Friday at 6 PM UTC for BTLO Replay. Thanks everyone, and see you next time.